Hi, boys and girls. Well, welcome to our very last video lesson, Chapter 11. Our very last video lesson of the year. Our very last video lesson in your pre-calculus high school math class. Boo-hoo. Here we go. Limits as x goes to infinity. By definition, if you take the limit of any power of x, if x is in the denominator of a fraction, as x goes to infinity, that limit is 0. As we know, as the denominator of a fraction gets larger and larger and larger, the value of our fraction becomes closer and closer to 0. So as x gets infinitely large, the value of our fraction gets infinitely close to 0. And we talked about this when we did horizontal asymptotes in rational functions way back in chapter 2. Okay, let's do one right here. Find the limit of the function 5 over x as x goes to infinity. Well, by definition, that limit is 0, because as x becomes a larger and larger number, 5 over a very large number gets closer and closer to 0. So as x gets infinitely large, the value of our fraction becomes 0. And we're going to use, again, the idea that any constant over some power of x, as x goes to infinity, that limit is 0. So let's try this one. Find the limit as x goes to negative infinity. It doesn't matter that it's negative infinity, it's still very, very large. Okay, so what we're going to do is we're going to use what we call the dividing out technique. We did this way back in chapter 2 when we found the horizontal asymptotes. But what we're going to do is we're going to take our fraction and multiply by the highest power of x in the denominator all the way around. So we're going to take each of my terms and divide by x squared, because x squared is the highest power of x in the denominator. So I have 3x squared over x squared plus 1 over x squared. All of that is over 4x squared over x squared minus 5 over x squared. Well, looking right here, these x squareds cancel. These x squareds cancel. So up top, I have 3 plus 1 over x squared. Well, as x gets large and large and large and large, that of course becomes 0. Over 4 minus 5 over x squared. But again, as x squared becomes larger and larger and larger, this limit is 0. Just like this limit is 0. This limit is 0. When I'm all said and done, I have 3 plus 0 over 4 minus 0, which is 3/4. And voila, there is my limit. Okay, so let's look at this guy right here. I have 4y to the 4th over y squared plus 3. I want to find the limit as y gets infinitely large, as y goes to infinity right here. So again, my highest power of y in the denominator is y squared. So I have 4 y to the 4th divided by y squared. I'm going to divide every term by y squared over y squared over y squared plus 3 over y squared. Now, up top, my y squareds will cancel, and I'm left with 4y squared over, here my y squareds cancel and become 1, plus 3 over y squared. Well, as y becomes infinity, 3 over y squared becomes infinitely close to 0, so it's 0. So it looks like I have 4y squared over 1. But as y approaches infinity, 4y squared gets infinitely large. So this limit is infinity, which means it technically does not exist. But in class, we'll just call a limit as it approaches infinity, infinity. Of course, infinity has no value, and that's why it does not exist. Okay, the rest of this video, at least in the year 2016, is for our level 1 kids only. So if you're a level 2 kid, sayonara, see you tomorrow, ciao, hasta la vista, adios. You can turn this thing off. For you level 1 kids, let's keep going. Let's find the limit of a sequence. In other words, find the value of our nth term of a sequence as n goes to infinity. In other words, what is the value of the term of a sequence as the sequence goes on forever? It's the same idea. So, find the limit of a sequence as n goes to infinity. So all we do is the same thing now. We have the highest power of n in the denominator of our term is n squared. So we're going to take every term and divide by n squared. Up top, one of the n's cancel, and I'm left with 1 over n. Here my n's cancel, I'm left with 1 plus 1 over n squared. Well, as n goes to infinity, by definition, this becomes 0. This becomes 0. So it looks like I have 0 over 1 plus 0, which of course is 0 over 1, which equals 0. And so, therefore, the limit of that sequence as n goes to infinity is 0. Why don't you guys try this one yourselves right now? We've done this a gajillion times. You probably already know the answer just by looking at it. But write out your work, stop the tape, and see what you get for a limit as n goes to infinity.